Picture a state-of-the-art control room or, a sprawling sports bar. You're looking at these massive video walls and matrix switchers.
Right, the gear that's simultaneously routing 4K video to dozens of different screens without even a hiccup.
Exactly. And it looks completely seamless, but there's actually this massive vulnerability there that nobody really thinks about until, well, all those screens suddenly go black.
Because all of that highly complex networking gear relies entirely on something we usually take for granted, which is just the raw power coming out of the wall.
Right. So that is our mission today. We are doing a deep dive into the invisible foundation that keeps these massive AV and IT ecosystems alive. Specifically, we're looking at the SurgeX 5814479R 1440VA line interactive UPS.
Which is, quite a mouthful of a name, I know.
It really is. But let's break that down first. The 1440 VA part, that tells us its power capacity, right? Like how much gear it can actually support.
Yeah, exactly. And the line interactive part means it's not just a passive battery waiting for an outage. It is actively conditioning the power coming in from the utility company.
Right, before it ever reaches your expensive equipment. Because, and this is kind of wild, electrical power isn't just binary.
Oh, not at all. We assume it's just on or off, but it's actually full of, microscopic fluctuations, surges, electrical noise, all that stuff.
And feeding that unpredictable, dirty power into a sensitive microprocessor is basically a recipe for crashing systems.
Yeah, or long-term hardware degradation.
Yeah.
It just slowly wears the components out.
Which brings us to the key component handling this in the SurgeX unit, which is the built-in isolation transformer.
Right. This is a really critical piece of the puzzle.
So I always picture this like a high-end water filter for your electricity. We want pure power flowing into a $10,000 video switcher without all the electrical contaminants.
That's a great analogy, actually.
But mechanically, how is this transformer actually filtering the power?
Well, it relies entirely on magnetic fields. So an isolation transformer literally separates your equipment from the raw utility line.
Wait, really? So there's no direct physical wire connecting them?
Nope. There is no direct physical electrical connection between the wall and your gear. The incoming power creates a magnetic field, and then that field generates fresh, clean power on the other side.
Oh, wow. That's crazy.
Yeah, the physical electrical noise and interference simply can't bridge that magnetic gap.
Okay, so filtering the noise is one thing, but the actual delivery of the power matters too. I noticed the specs highlight a 0.9 power factor.
Yes, very important metric.
But does a 0.9 power factor just mean, it operates at 90% thermal efficiency, so it wastes less heat?
Not quite. Thermal efficiency is actually a different metric altogether.
Oh, really?
Yeah, power factor is the ratio of the real power being used versus the apparent power being drawn from the circuit.
Okay, tracking so far.
So a 0.9 power factor means 90% of the current drawn is doing actual useful work.
Got it.
And why that matters to IT teams is that the unit draws less overall current to do the same job, which frees up electrical capacity on that circuit.
Ah, and prevents your breakers from tripping under heavy loads.
Yeah. Exactly. Highly efficient with the circuit's capacity.
Right. But I'm still kind of stuck on why AV and IT setups require this specific unit's true sine wave output.
Oh, yeah. That's a big deal.
Because if I just need a battery to keep my servers up during a blackout, why can't I just grab a cheap $50 backup battery from a big box store?
Well, it comes down to the physical shape of the power. Cheap backup units output a simulated sine wave.
Simulated, like a knockoff wave.
Yeah, basically, if you look at it on an oscilloscope, the electrical wave is blocky and jagged. And sensitive control systems look at that jagged power and basically reject it.
Oh, yikes.
Yeah, they might reboot, throw errors, or even sustain internal damage.
Mm-hmm.
But a true sine wave is perfectly smooth and continuous, mimicking the ideal power a utility company is actually supposed to provide.
Wow. And the SurgeX scales that smooth power depending on your setup, too. You can get the standalone 2U unit. And 2U just means it takes up 2 standard vertical slots in a rack, right?
Yes, it's your standard footprint.
But if your environment requires a longer bridge during an outage, there's also a bundled system that includes an extended battery pack.
You basically tailor it to the environment. A broadcast studio might need that extended pack to keep a live feed running for an hour.
Whereas a smaller control room might just need the standard 2U unit to buy enough time to safely power down their servers.
Exactly, just enough time to avoid data corruption.
Because modern infrastructure is ultimately only as reliable as its foundation. And a device like this provides the uninterrupted, clean power that ensures high-stakes environments don't just collapse when utility power fluctuates or fails.
Yeah, understanding that power is a flow that needs constant conditioning, it completely changes how you look at the physical infrastructure keeping our digital world online.
It really does. So for you listening, think about the devices in your own home or office right now.
Oh, yeah, that's a great point.
We focused on massive control rooms today, but how much invisible, unfiltered electrical noise is slowly degrading the performance or the lifespan of the electronics you rely on every single day?